SwayamPrabha. Digital India. Educated India.
Welcome viewers to the 14th lecture of the online course Metal Cutting and Machine Tools. So, today after finishing the previous lecture on lathe, I could feel the requirement for some discussion on the typical mechanisms that we would be coming across on the lathe, on the milling machine, etc. So, I have slightly changed the course of the lectures and included a small discussion on different types of mechanisms. Okay. So, some simple calculations are included. Let us move right away into the calculations. So, 14th lecture, calculations pertaining to machine tools. First of all, calculations pertaining to gears. Okay. We have a gear train and we are given, what are we given? The gears have been represented in a simplified form, that is understood. They are represented as circles seen from an angle. So, in this particular view, we are seeing gear numbers mentioned to identify them, and numbers of teeth have been mentioned as Zi. So, Z1 represents the number of teeth of gear 1, Z2 represents the number of teeth of gear 2, and their rotations per minute of the first gear has been mentioned. So, this is the input. So, we understand that, just a moment, where is this? Yeah, this is the input rotation 40 RPM. So, if 40 RPM is the input rotation, the question is what is the rotations per minute of the fifth gear, fifth gear, the last one in the train. So, gear 1 is rotating gear 2, gear 2 is on the same shaft with gear 3, gear 3 is rotating gear 4 and gear 4 is on the same shaft as gear 5. If two gears are on the same shaft and they are integral, in that case they will share the same rotations per minute. Their RPM will be the same or their angular velocities will be the same. What about two gears which are connected like this in mesh? They will have the same tangential velocity. With respect to this tangential velocity, let us finish a quick calculation. First of all, this is one gear and say this is another one. These are their pitch circumferences. So, they are in contact with each other here, and I draw the teeth of one gear this way. And I draw the teeth of the other gear here. Like this. Though the drawing is not very perfect, I think we can continue our discussion with these these geometry elements in view. These are the teeth of the gears. If this gear is rotating, the other gear is made to rotate. And we understand that in order to have this meshing or this interconnection between two gears, on the pitch circumference, this distance from here to here, okay, this one has to, this one distance has to accommodate, or rather this one gear tooth has to be accommodated by this particular corresponding distance on the other gear, and this distance has to accommodate the gear on the other side. So, we can say these two distances have to be the same on these two gears. And what is this basically? It is pitch circumference divided by the number of teeth. So, we can write pitch circumference equal to pi dp, where dp is the pitch diameter. What is the pitch diameter? Pitch diameter of a gear is defined as that diameter of two gears in mesh. So, let me draw this. If two gears are replaced by two circles rotating against each other without slip to produce the same RPM ratio as that of the two gears. In that case, those two diameters are referred to as the pitch diameters of the two gears. So, I have two gears, I replace them by drums rotating against each other without slip and producing the same RPM ratio. Then those particular diameters are called the pitch diameters of the two gears. So, I am saying pitch on the pitch circumference, this distance is nothing but pi dp1 by z1. Z1 is the number of teeth on the first gear, 1 and 2. This must be equal to, from whatever we have discussed here, this must be equal to pi dp2 by z2. So, that pi cancels and I have dp by z is a constant. dp1 by z1 is equal to dp2 by z2 is equal to dp3 by z3 is equal to dp by z, a constant for meshing gears, and this one we give a name. So, let us select a new page. dp by z is constant for meshing gears and it is given a name called module. So, if you go to the market and say that I want a gear of 32 teeth, the question that the shopkeeper will ask you is that what is your module? Module in inch system is slightly defined slightly differently, but to keep the discussions clear and easy to understand, we will stick to basically module. There we have the existence of diametral pitch, which is equal to z by dp, where dp is in inches, but we will restrict our discussion to module. So, this point is understood. Gears which mesh with each other have a constant module or equal module, and module differentiates families of gears which mesh with each other. So, now that we have understood, let us go back to our discussion of gears. So, we express two gears this way, and then we say that suppose this one gear and this is gear number 2, they are in mesh with each other, and this has say 40 teeth, Z1 equal to 40 and Z2 equal to 20. And in that case, if N1 is given to be 1000 RPM, what is N2 equal to? What is the value of N2? So, in that case, how do we solve it? We first of all say that, as we observed last time, this particular velocity is shared, V1 is equal to V2. Okay? Just a moment. If V1 is equal to V2, we can say V is nothing but equal to R omega. So, naturally, we have R1 omega 1 equal to R2 omega 2, and for our convenience, let us replace R by D, D1 omega 1 is equal to d2 omega 2, which means d1 into, and we replace omega by 2 pi n by 60 equal to d2 into n1 2 pi n2 by 60. All these things will cancel out, and we have d1 is equal to and we have d1 n1 equal to d2 n2. Okay. So, let us select a fresh page and write here d1 n1 equal to d2 n2, and therefore, since we have found previously d by z, dp and d here they are the same things, d by z is equal to module. Okay. I can replace here d with m into z1 into n1 is equal to m into z2 into n2. Sorry, this one is a mistake on my part. Module is the same for meshing gears. Hence, I cancel out module and I have n1 z1 equal to n2 z2, and therefore, if we go back to the problem. So, this is what we are going to use now, and if we go back to the original discussion, we find z1 is given, n1 is given. So, let us solve it right away. We have n1 z1 equal to n2 z2 for these two meshing gears. Therefore, I can say that n2 can be found out as n1 z1 40 multiplied by 210 divided by z2. How much is z2? z2 is 42. Achha. 42 goes into this 5 times, I hope. 42. 21 goes into this twice, and on this 10 times, and you can cancel it further. 5, yes, 5 into 40. So, this is going to rotate at 200 rpm. N2 is 200 rpm. So, this is also going to rotate. N3 is going to be the same as per our previous discussion, 200 rpm. Let us apply the same thing here. N3 Z3, that means 200 into Z3, 84 must be equal to Z4, 42 into N4. That is good. So, we have this one cancelling out twice, and therefore, we have N4 is equal to 400. N4 is equal to 400, and they are sharing the RPM. So, this will also have RPM equal to 400. N5 is 400. The RPM of the gear 5 is 400. This one is correct. Okay. You might say, what about Z4? Didn't it have some role in the deciding of the RPM? No, it is rotating in air, not in connection with anyone. So, it has absolutely no role here. Achha, okay. So, just one thing I would like to mention here before we move on to the next subject. If you have a shaft in which you have a gear and you have another gear, another shaft, and you have yet another gear, another shaft. In that case, what happens is, if this is number 1, number 2, number 3, you can connect up N1 Z1 is equal to N3 Z3 directly, instead of considering about 2, because 2 in this case is called an idle gear, because in the other view it will look like this: gear number 1, gear number 2, gear number 3, and they are rotating this way, and therefore, they have the same tangential velocity. This tangential velocity, say let us call it V1 and V2, they are the same. V1 and V2, they are the same. What does that mean? That means that I can directly establish the equality of velocities between these two elements. That is it. Okay. So, having established this one, we will be utilizing all these results extensively in our discussions. So, this answer we have already established is 400. Let us move on to the next subject. Oh my God, quite an elaborate example. So, I will come back to this one. I will come back to this because at this moment we are not having any knowledge of what should be the speed ratio between worm and worm gear. Let us discuss all those aspects. This is a threaded element. What is the meaning of a threaded element? It means that on the circumference of a, let me draw it, on the circumference of a cylinder, outer wall of a cylinder, suppose I am climbing up. You have all seen spiral stairway, maybe all of you have visited places like the Qutub Minar. I do not know during your time whether you are allowed to move up the Qutub Minar, but in our time we were allowed up to a certain, I think the first story, and it was a helical climb. Okay. There was a helix, that means a helix goes all around the cylinder and it rises while it is rotating all around. Okay. It rises while it rotates, that is a helix. So, whenever we are having such such helices, okay, in machine tool elements, I mean machine elements, okay, they serve some purpose. They can be used as clamping devices, they can be used as devices for deriving motion, etc. And therefore, we come across today's discussion about screw threads. Screw threads. Okay. Let us see how they help us. First of all, what is this screw thread doing? What information does it give us? For example, in a screw thread you will find that there are some typical definitions attached to it. What sort of definitions are these? For example, distance between similar successive points on a thread. So, first of all, this is a helix. Similar successive points on a thread, it is called pitch. This one is called pitch. So, what is so great about that? You will find surprisingly that there is not a single helix in this one, but there are two parallel helices. This is helix 1 given a different color, helix 2, helix 3, helix 4, like that. What does it mean? It means that this is helix, sorry, I should not have written helix 1, helix 2, this will unnecessarily confuse you. This is helix 1 only continued. What does it mean? It means that this helix is absolutely independent from that one. They are climbing parallelly. Okay. How does it show up on the cylinder? If this is the cylinder, it shows up this way. This is one helix climbing up, etc. Helix 1. So, it moves all around this way, and there is yet another helix. Say, let me give it a different color. It is this one, sorry, it is same color. Just a moment. Oh, I could not change the color. So, I can change at least the form. There is yet another helix moving this way. Okay. So, parallel helices, just like you have spiral stairways, two parallel spiral stairways. What purpose does it serve? In this case, it is always referred to, if you have 3 helices or 4 helices, or 5 helices, it is called multi-star threads. Multi-starred threads. What purpose do they serve? In that case, if you have a nut connected to it, just a moment, yeah, if you have a nut connected on that, nut is a device which has fitting grooves on it into which these threaded elements can be fit in. Okay. So, this is the nut. If you rotate the screw and if you hold the nut steady so that it cannot rotate, it will execute translational motion. Now, if for single start threads, if let me write, if n is equal to, sorry, if k equal to number of such helices, separate helices, it is called number of starts, equal to 1. In that case, the movement of this nut past the screw, I mean if it is not allowed to rotate with the screw and if the screw is not allowed to translate, in that case the movement is pitch into RPM. So, we can write nut velocity. Velocity of the nut will be equal to pitch multiplied by the RPM. Let us have an example. Suppose the rotation of the screw, RPM of screw is equal to 1000 RPM. So, in that case, if pitch be equal to, nut pitch and screw pitch has to be the same, otherwise they will not match. Nut pitch is say 4 millimeters. In that case, this will be equal to 4 multiplied by 1000 equal to 4 meters per minute. Just imagine 4 meters per minute will be the movement of the screw if number of starts is equal to 1. However, if there are 2 starts as shown in this figure, there is another term defined, there is another term defined which is called lead, while this was your pitch. So, we have lead equal to k into pitch, okay. K is the number of starts and equal to movement of nut due to 1 rotation of screw. So, ultimately it boils down to the fact that if the nut if the nut and screw they are of multi starts, say they are of double starts, in that case if you rotate the screw once, the nut does not rotate by the pitch, but it rotates, does not move by the pitch, but it moves by the lead, where lead is equal to number of starts into the pitch. Okay. Having established that, we understand that this is the way in which the nut and screw work. Now, let us move on to the last machine element pair that we have to discuss, the worm and worm gear. What is the worm and worm gear? For that, let us now at this moment, let us identify the worm by simply referring to it as a threaded element. Just a moment. By simply referring to it as a threaded element. So, this is our worm. So, why are we suddenly bringing in this term? Because it is when it is coupled by another machine element, it forms the very popular device for speed reduction called the worm and worm gear. So, what is the worm gear in connection with the worm? The moment people started thinking about different machine elements, at one point in time they connected up two different machine elements, the screw and the gear, so that they made this sort of a connection. Like that, which means that if the screw is rotating, the worm gear will have to rotate with it. Okay? In which way? That is, tooth by tooth, this particular helix, as it is slightly inclined, these points will be coming sequentially and they will be pushing the wheel, toothed wheel, to one side, and this is called the worm gear. So, what is so great about it? The thing which is great about this machine element pair is that it can bring in huge reduction in speed only in one stage. Generally, if you are trying to reduce the speed, maybe with the help of sliding clusters, you can reduce the speed by say a factor of 1, a factor of 2, maximum maybe 3, but not more than that at one stage. But at one stage itself, the worm and worm gear can reduce the speed by a factor of 40. Just imagine, factor of 40. What is the speed ratio? So, the speed ratio of the worm and worm gear is equal to N worm gear. Why is it called the worm? Because it looks like an earthworm, that is why. N worm gear divided by the RPM of the worm is equal to K by ZWG. Let me draw it a bit more clearly. N worm gear divided by N worm is equal to K by ZWG, where ZWG is equal to number of teeth on worm gear. What is the worm gear? The one which is connected to the screw, and K is already defined, number of starts of worm. So, having understood this, we see that the ratio of these two speeds can really be very small. In what way? Suppose K is equal to 2 and suppose ZWG is equal to 80. So, this will be equal to 2 by 80 equal to 1 by 40. Okay. So, this is the capability of this device, and we will have extensive use of it in our mechanisms. So, with this one, let us quickly go to the previous slide in which we had some discussion on this. Sorry. Just a moment. Yeah, this is the one. This is the one. Let us quickly solve this and end our class today. The motor rotates at 1440 RPM. ZWG refers to the number of teeth on the worm gear in connection with the worm. That is understood. The speed of the rack in meters per minute will be nearest to. So, what do we have here? The motor connected to the worm, number of starts is equal to 2. This is the worm gear, its teeth have not been shown. Number of teeth on the worm gear is 40, and on the same shaft we have another gear where the number of teeth is equal to 32. That is in connection with a gear B whose number of teeth is equal to 30, and that is in connection with a straight sided gear called a rack with module 2. We have to find out the speed of the rack in meters per minute. So, let us move right away. 1440 RPM, sorry. (1440 RPM). is the RPM of the motor. We start from the motor. Next we come to the worm gear. Worm gear converts this RPM, I mean the worm and worm gear pair changes this RPM as per its speed ratio. So, speed ratio is already known, K by Z, K by Z, which means this is nothing but 1440 multiplied by 2 divided by 40. Okay. So, this part so far so good. So, this is now can be removable. We have moved up to the worm gear shaft. That shaft is containing this gear. So, it must be having the same RPM. So, this must be equal to the RPM of gear A. So, this is also equal to NA. That is good. Therefore, we move 1440 into 2 by 40 multiplied by, NA ZA will be equal to NB ZB equal to, what is this? Just a moment. Okay, let it be, into NA ZA 32 must be equal to NB ZB equal to 30 multiplied by NB. Now, how much is that? We have let us have a quick cut. 0, 0 cancels, this one cancels with this, 4 8s are 32, 16, 16, this 2 let it go with this one, 15. So, we have how much? 8 here, 1440, 144 into 8 divided by 15. Okay. NB equal to 144 into 8 divided by 15. Okay. What do we have here? After this, the rack is being moved due to its connection with ZB. What is the speed of the rack? Now, they must be sharing the same velocity here. What is this velocity? It must be number of rotations multiplied by the circumference. In one rotation, it moves by the circumference. So, in n number of rotations, it must be moving by n into the circumference. So, n is this. So, we have the velocity to be, velocity is equal to 144 into 8 divided by 15 into, as we discussed, into the circumference. Circumference is pi into d. What is d? D is equal to module into z. So, module is 2 m into z equal to 144 into 8 divided by 15 into pi into 2, module is 2 into 30, that is it. This should be the answer, 2, 4. So, 4 8s are 32, once again 32 into 144 into pi. So, this has been named as the correct answer in meters per minute. All these things were in millimeters. So, we will have divided by 10 to the power 3. Okay. I leave it to you to check whether this one is correct. Let me write it down, 32 144 pi. Please check yourselves. 144 into 32 pi divided by 1000. Is this equal to this one? You have to check. Okay. So, with this we come to the end of today's discussion. Thank you very much.